Hey guys, this is Unit 4, Notes number 1. We're going to start off with an application of what we've been learning. It's called related rates. Make sure that you have a calculator handy. You will need it. So before you continue, make sure that you have that with you, okay? Okay, here is your FLT. Given an equation and specified values, you're going to be able to apply the concept of related rates and implicit differentiation to find the desired value. So it looks like a lot, but let me just break it down like this. Oftentimes, you will have many moving parts to a problem. Okay? So this is just one quick example, but let's say you had a car that was traveling in one direction here, okay? And then you had another car that decides to go east, traveling in a different direction. So these two cars are actually driving at two different speeds, okay? Now, what does that do to the distance between the two cars at any given moment, right? So if you think about this logically here, the further and further we go with time, okay, the further and further these two cars are going to be apart, assuming that they don't change direction. So if the first car goes all the way upwards and the second car goes all the way to the right, the orange dotted line, or the distance between the two cars, will only get larger and larger. It will increase, right? But how fast will it increase? So if you notice, there are three different rates here. There's the rate at which the first car is moving, there's the rate at which the second car is moving, and then there's the rate at which the distance between them is changing. So again, there are a lot of moving parts, but all of these different rates are related, hence related rates, okay? So what that has to do with is, I'm going to show you in the first example, it applies what we've learned before with implicit differentiation. Feel free to pause here if you want to look back at what that means and what that did before you continue, okay? So we're actually going to spend 2 lessons on this. So we'll start off with something basic, not too applicable just yet, but something a little bit more concrete. So here's example 1. Okay. Go ahead and write this one down. Everything else we'll shorthand afterwards, okay? And then press play whenever you're ready. So here we have this rectangle that has a length of 9 inches and a width of 12 inches, whose sides are changing. So let me give you the scenario here. So you have, and this is definitely not to scale, okay? You have this rectangle and it's changing in size. So if you read a little bit more, it says that the length is increasing by 3 inches per second and the width is shrinking. So it's kind of hard for me to do, but just understand that this rectangle is changing in size, okay? So specifically, we know that the rectangle is currently 9 inches long and 12 inches wide. And it could be the other way around, but it really doesn't matter. Okay? Now, it tells you that the length is increasing by 3 inches per second and the width is shrinking. So, to kind of illustrate this here, this length is getting longer. It's increasing, okay? And then the width is actually getting smaller, so it's decreasing. Okay, so if we were to just pan this out in like a certain amount of seconds, you'll get something that's really long but really short, depending on how much time has elapsed here. Okay, so again, there are a lot of moving parts. What does this all mean? Okay, let's keep reading. What is the rate of change of the perimeter? Okay, so some things that you want to highlight so that we can shorthand later. Let's highlight some of the key components here. We know that this rectangle, as of now, has a length of 9 inches and a width of 12 inches. But we notice that the sides are changing. Okay? The length is increasing by 3 inches per second, and the width is shrinking at 8 inches per second. So the first step here is you want to write down everything that they give you. Okay? So I'm going to write it down with you. We know that the length is 9 inches. We know that the width is 12 inches. Okay? We know that the length is increasing by 3 inches per second. So this is loaded right here, okay? But let me break it down so it's easier for you to understand. The length is increasing by 3 inches per second. Okay, so think back, all right, to graph analysis. When something is increasing, what does that imply? Okay, I'll let you pause here and play whenever you're ready. When f is increasing, its derivative is positive. Okay, and vice versa. Okay, when f is decreasing, we know that the derivative is negative. So this all comes back. The gardener decides to come right when I'm recording. This is awesome. Okay, so knowing that the length is increasing, that tells me that the derivative is positive, meaning that the rate is positive. So the way that you would write this is L, you're going to do dl over dt to indicate the rate at which the length is changing. Okay? We know it's increasing, so the derivative has to be a positive 3 inches per second. Okay? Now the other rate, they mention about W, okay, the width is shrinking, but it's still at a rate, so it's going to be dW over dt. Okay? Anytime you guys want to write a rate, it's always going to be d something over dt. Now, because the rate of the width is shrinking, we know that it's going to come out negative 8 inches per second. Make sure that you guys understood that part before you move on, okay? Okay, so we jotted down everything that they gave us. Now we need to obtain some type of equation, okay? And they give it to us right here. What is the rate of change of the perimeter, okay? So first off, what you're going to do is you write down the equation of a perimeter. Okay, what's the equation of the perimeter of a rectangle? Press play whenever you're ready, okay? The perimeter of a rectangle just means you adding up all 4 sides. So there are 2 lengths and there are 2 widths, okay? So this is where implicit differentiation comes in. If you want the rate of change of the perimeter, that's going to be d over dt of something. So in this case, we're finding the rate of change of the perimeter, so that's dp over dt. The only way to do that is we are going to take our differential. The differential of p is just 1, but with respect to p. The differential of 2L is 2, but with respect to L. The differential of 2W is just 2, but with respect to W now. Remember, we're just finding the derivative with respect to that variable, okay? Okay, what do we do after we find our differentials? We divide everything. Now, since we're dealing with related rates, we are always going to put it with respect to time. Okay, so all over dt, every single time, you guys, okay? Okay, so look, we just plug in what we know. We want to know what dp over dt is, so this is our unknown value. Okay, so let's plug everything in. 2. So dl over dt is positive 3 inches per second. Okay. Plus 2, and dw over dt is negative 8 inches per second. This comes out to positive 6 minus 16, which is negative 10. So in short, this is your answer. What does this mean? This means that your perimeter is decreasing. Your perimeter is decreasing at 10 inches per second. Okay? We know it's decreasing because of that negative, all right? And there you have it. Okay, it looks weird at first, but let's do a couple and make sure that you guys are comfortable, okay? Okay, here's part B. Press play whenever you're ready, all right? Okay, so here, let's highlight what's important. We have a length of 2 inches, a width of 11 inches. Length is decreasing by 2 inches per second. Width is shrinking at 8 inches per second. What is the rate of change of the perimeter? Okay, we jot down what we know. That's the first step. Length is 2 inches. Width is 11 inches. The length is decreasing by 2 inches per second, so that's a rate, because a rate is just a fraction. So 2 inches per second is a rate. Since it's decreasing, I know it has to be a negative, and that's going to be dl over dt since it's a rate, okay? The width is shrinking at 8 inches per second. Well, width indicates that it's getting smaller, so it's a negative 8 inches per second. And that'll be dw over dt because that's a rate. So we need to find the rate of the change of the perimeter, which is 2L plus 2W. And rate of change just means derivative. So that's dP equals 2 dL plus 2 dW. And then we're going to divide every differential by dt every single time. Okay? And then we plug in what we know. dP over dt is equal to 2 times dl over dt is just negative 2 inches per second plus 2 times dw dt, which is negative 8. Okay? This comes out to negative 4 minus 16, which is negative 20 inches per second. Okay? Which means that the perimeter is decreasing at a rate of 20 inches per second. Decreased because you ended up with a negative answer, okay? Now, some of you might be thinking, well, what was the point of having this, right? What was the point in having the lengths? Okay? Well, in these cases, we didn't really have to use it, but you'll see that it's important that we write everything down because in the more complex problems, you're going to have to use pretty much every information that you're getting, okay? Let's try another one. Okay? You can go ahead and write down what you think is important if you want to shorthand this one. But I'm going to start highlighting here. We know that there's a rectangle that has a length of 1 inch, a width of 7 inches. Length is increasing by 5 inches per second. Width is growing at 7 inches per second. But here, what is the rate of change of the area? Which is a little bit different. But here we go. Write down what we're given. Length is 1 inch. Width is 7 inches. Length is increasing, so dl over dt is a positive rate of 5 inches per second. Okay? The width is growing at 7 inches per second, so dw over dt is going to be a positive 7 inches per second. Positive because it's growing, okay? Now, what is the rate of change of the area? Okay, so notice how we don't use perimeter here. Area of a rectangle, you guys know as length times width. Okay, so the equation changes, so how we take the derivative or the differential changes a little bit. So here we go. The differential of A is just dA. Okay, now remember all of those rules that you guys learned in the previous lessons still apply. This is a product, so we have to apply the product rule. So that's going to be the first times the differential of the second plus the second times differential of the first. Okay? Replay that if you need to. We're going to divide every differential by a dt, always with related rates, okay? Okay, what is the rate of change of the area? It's easy enough because what we're looking for is already isolated, so we'll just bring that down. Now L, what's our length here? Our length is 1 inch. I'll just put 1 for now. Actually, you know what? I'll put 1 inch to prove a point later. dW over dt is positive 7 inches per second plus W is 7 inches and dL, let me scoot this over. And dL over dt is positive 5 inches per second. Okay? 1 times 7 is 7. And 7 times 5 is 35. Okay? If you guys take a look here, I'm multiplying inch with inch. So that is actually inches squared per second. And this is also inches squared per second. Okay? So that gives me a positive 42 squared inches per second. What does this all mean, right? Okay, so first off, that's your answer. What this means is that the area is increasing at a rate of 42 squared inches per second. Okay? Now, why did I include units this time, okay? This is actually how it plays out. Now, you could totally avoid this. For instance, let's say you didn't write units, right? You would have something that's bare like this. Okay? Here's how you have to think about it. Just think about what this represents. A represents area, and T represents time. Okay? Time, in this case, is represented as seconds. So I'm going to put seconds down here. Area, if you remember area is always measured in squared units. So in this case, it's going to be squared inches. I talk about this because when you get to your FRQs in your AP exam, they do ask you for units. And these are the easy points that you don't want to miss. Okay? So in this problem, we actually did use the length and the width this time. It just depends on the context. All right? Okay. Here's example D. Okay? I would write this one out in its entirety because it is different. Press play whenever you're ready. Okay, so we have a right triangle that has legs of 36 inches, 48 inches, and again, the sides are changing in size, right? The short leg is increasing by 5 inches per second. The The long leg is growing at 2 inches per second. And the big question here is, what is the rate of change of the hypotenuse? Okay, so let's draw a picture. We have a right triangle. Okay. We have legs that are 36 and 48 inches. So let's make the shorter leg look like 36 inches and the longer leg as 48 inches. Okay. Now we know a few things. So let's write this down. So let's give it some variables, okay? Just to make sure that we're all on board here. We can use, usually when people see a triangle, they'll use either maybe X, Y, and Z. Some people might use A, B, and C. It really doesn't matter, okay? But for the sake of argument, I'm just going to use A and B. So let A represent the short leg and B represent the long leg. And C will be your hypotenuse. Okay? All right, so we know that A is 36 inches. We know that B is 48 inches. We know that the short leg is increasing by 5 inches per second. 5 inches per second is a rate. And since it's increasing, I know it's going to be a positive, okay? So since this is a rate, this is going to be d something over dt. Now, since the short leg is increasing, this will be dA over dt, okay? And then it says the long leg is growing at 2 inches per second. So 2 inches per second, since it's growing, it's going to be a positive. And since it's growing at a rate, it's going to be d something over dt. In this case, it's going to be dB over dt since it's the long leg. Okay. Now they're asking, what is the rate of change? Remember, rate of change is derivative of the hypotenuse. They're really asking us to find what dc over dt is, because rate of change is d over dt and hypotenuse is c. So here is where it gets a little challenging, because they didn't really give you an equation to deal with, okay? So you guys have enough knowledge here. Using this picture, okay, what equation will incorporate all three sides here? Okay, so some of you might have guessed it. It is the Pythagorean Theorem in this case, okay? We wouldn't use the area formula because the area formula does not include the hypotenuse, okay? So I would use a squared plus b squared equals c squared. Okay, that's probably the most challenging part, but after you get through that, it should be easy. We're going to go ahead and take the differential. So the derivative of a squared is just 2a, but the differential is with respect to a, plus the differential of b squared is going to be 2b with respect to b. And I'm running out of space. Let me scoot this over. Okay, and the differential of c squared is 2c, but with respect to c. Okay, replay this as much as you guys need to. It is new information, okay? We're going to go ahead and divide every differential by dt because time is elapsing, okay? Okay, so there are two ways that we can handle this. Our job is to figure out what dc over dt is, which is right here. And it's not isolated at the moment, okay? So you could either decide to isolate it now or isolate it later, okay? So here's what we're going to do. I'm going to plug everything in first, okay? Let me scoot this one over so that's not in our way. Okay, here we go. We have 2 times a, which is 36, okay, times dA over dt, which is positive 5, plus 2 times b, which is 48, times dB dt, which is positive 2, equals 2. Wow, I'm running out of space. Let me scoot that over a little bit. Okay, equals 2 times c times dc dt. So here's the thing. What the heck is our c value, right? We're actually missing a value here because we can't have two unknown variables. We already need to figure out what dc dt is. So what's c? So remember that this is a right triangle, and we could actually find out what c is given our two sides. So sidebar here, we know that 36 squared plus 48 squared will equal c squared. So I'm going to have you guys pause here. Press play when you figure out what c is, okay? Okay, so c, if you did it right, it should come out to 60. It's not plus or minus because that minus doesn't make sense for a negative length, okay? So with the Pythagorean Theorem, we found out that this was 60, okay? Here's what we're going to do. We're going to go ahead and plug this in to our calculator, okay? The right side here I'll do because it's easy. That's just 120 dc dt. Okay, but let me go ahead and multiply this out. 2 times 36 times 5 plus 2 times 48 times 2. So you should get 552. Hopefully I did that right. Equals 120 dc over dt. Last step, divide the 120. That comes out to 4.6 positive, okay? Since c is just a side, this rate is just going to be inches per second. It wouldn't be inches squared because it's not area, okay? So what this is saying is the hypotenuse will be increasing at a rate of 4.6 inches per second. I'm going to wait for the gardener to stop. Okay, here's the last one while I wait. Here's part E. Go ahead and write this one down. So let's highlight some of the important parts, right? There are two given lengths for the legs of a right triangle. Short leg is decreasing, long leg is shrinking. Something a little bit different. What is the rate of change of the area? Okay, so let's say A is the short leg, so that's 27 inches. B is 36 inches, the longer leg. The short leg is decreasing by 9 inches per second. Decreasing implies that it's a negative rate. And since it's the short leg, it'll be dA over dt. The long leg is shrinking, so that's going to be negative 2 inches per second. And that'll be dB over dt. Okay? So here's a quick picture. Okay, now what's different about this last one here is if you guys read the question, it's asking you what is the rate of change of the area. So remember, rate of change is just d something over dt. So we're finding the rate of change of the area. This is what we're trying to figure out. So this tells us that we should use our area equation. What's the area of a right triangle, right? Area of a right triangle is 1/2 base times height. Okay, in this case, it's going to be 1/2 B times A if we're using the same letters. Okay, so here we go. Now that you have your equation, we have to take the differential. The differential here is going to be dA equals 1/2 is just a coefficient. Now BA is a product, so we're going to have to apply the product rule. Okay, pause here if you'd like to try it on your own, or if you want to just see how far you can go. Okay, and press play whenever you're ready. B times A is a product, so I have to apply the product rule. So that's going to be the first times the differential of the second plus the second times differential of the first. It gets a little weird because there's an uppercase A and a lowercase a. If that's confusing, I would encourage you to probably use X and Y instead, but it really doesn't matter. Okay? Okay, here we go. Now that we have our differentials, we're going to divide our differentials by always dt. Since we're looking for dA over dt, and it's already by itself, that makes our job a little bit easier. Here we go, 1/2. B is 36. dA over dt is -9. Plus A is 27. And dB over dt is -2. Okay, a lot of plug and chug here, you guys. Okay, I'm going to go ahead and do that real quick. 36 times -9 plus 27 times -2. And then I'll take half of that. So dA over dt is -189. Now, here's what I mean by units, okay? Just think about what you're dealing with. A stands for area. T stands for time. Time, what units of time did we use here? We used seconds. Now, area, how do you measure area? Area is always measured in square units. So in this case, it's going to be inches squared. That way, you could avoid all of the units in between here. Okay? This is saying, since the derivative of A is negative, that says that A is decreasing at a rate of 189 squared inches per second. Okay, this is just the introduction, you guys. It does get a little bit more complex, but practice it. I know it's new, but with a little bit of practice, you guys will be able to get there, okay? Text me if you guys have questions, and then we'll go from there.